Alright, this will be the recording for practice question 7 on distribution of sample means. So starting from question 1, I've already put the definitions here at the bottom of the page. So you can reference that. So I'll start with question 2. So question 2. Measures of variability. Comparing measures of variability, we have this is standard deviation for sample. This is a standard deviation for population, and then this is the standard error. So basically, the comparison would be this is the standard deviation for sample. This is the standard deviation for population. And this is the standard deviation for distribution of sample means. B, measures of central tendency. So we have M, we have mu, and we have mu M. So this one again is mean of sample. This is a mean of population. This is a mean of sample means. Which should be also the expected value of M. Theoretically, these two should be very similar. Okay, so this was question 2. Question 3. So question 3, if all possible random samples, each with n equals 9, the scores are selected from a normally distributed population with mu equals 90 and sigma equals 20. And the mean is calculated for each sample. Then what is the average value for all of the sample means? So again, as we kind of talked about, the question is asking about mu m. So basically, what is the mean of sample means, which in this case, since we are doing a random sample, and we're also finding all possible random samples with n equals 9, this should be equal to mean of our population, which would be 90. So basically the mean of sample means, or expected value of M, is equal to population mean. Okay, question 4. Sample is selected from a population with a mean of M equals 100 and a standard deviation of 20. So first, if a sample has n equals 16 in scores, what is this expected value of M and the standard error of M? So expected value of M, or mu of M equals mu equals 100, and then the standard error, we know it is equal to standard deviation of the population divided by a square root of n. So in this case, we know standard deviation is 20, and we know n is 16. So square root of 16, 20 over 4, which gives us 5. And B, we have sample of n equals 100. So we want to find, again, the same values. So mu of m equals 100. And standard error equals sigma divided by square root of n, which would be 20 divided by square root of 100, which will be 20 over 10 equals 2. Okay, so this was question 4. Question 5. Describe this distribution of sample mean, shape, mean, and standard error for samples of n equals 64 and mean equals 90 and standard deviation of the population is 32. So shape, first of all, for shape, we know since n is greater than 30, based on the central limit theorem, we know the shape will be normal, like the bell sign. And then the mean we know is equal to mean of population, which would be 90. And then the standard error will be standard deviation divided by square root of n, which will be 32 divided by square root of 64, 32 over 8, which is 4. So the shape will be the normal distribution. Mean is 90 and standard error is 4. Okay, let's go question 6. Under what circumstances the distribution of sample mean is guaranteed to be a normal distribution? So this again goes back to the central limit theorem. So under central limit theorem, we know that basically as the sample size increases, the distribution of the sample means it approaches the normal distribution, regardless of what is the distribution of the underlying population. So let's see what was the question. So I think based on that, one of the conditions is for n known to be greater than 30. It is basically if we consider n greater than 30 a large enough number, the basically is a great enough number that we can consider that as a normal distribution. Yeah, and then also as the sample size increases, closer to normal distribution. Okay. Okay, let's see. Let's look at the next question. Okay, so a random sample is selected from a population with a standard deviation of 18. Okay, let's see. Okay, let me go back to here. So let's see. We know that this standard deviation is 18. So A as on average, how much difference should there be between the sample mean and the population mean for a random sample of n equals 4 scores from this population? So what this is trying to ask is basically the standard error. To find the standard error, we know this is the formula. So for this case, we know that we have n equals 4. So, and then we have the standard deviation of the population of 18. So this is 18 divided by 2, which is equal to 9. But if you notice, this is basically the language that they use to refer to standard error. So on average, how much difference should there be between a sample mean and a population mean for a random sample of n equals 4? Okay, so let's go to part B. So this one, n equals 9. For A was 4, so the same thing. 18 divided by a square root of 9, which will be 18 divided by 3, just 6. And the same thing for part C, n equals 36, means that you have 18 over square root of 36, which will be 18 over 6, which gives us 3. So you can also kind of compare here that as with the same population or like population standard deviation, or if we like keep this constant, the standard error decreases as n increases. This we can also see that based on the formula. We can see that as the number of n increases, the standard error will decrease. So this was question 7. Question 8. For a random sample of n equals 36, what is the value of the population of standard deviation necessary to produce each of the following standard error values? So we know n, we know so each part gives us one standard error, and we want to see what is the standard deviation of the population. Again, so Yeah, so we know that the standard error is equals to standard deviation divided by a square root of n. So based on this, we can say that standard deviation equals to standard error times the square root of n. So we can use this form to find a standard deviation for each part. So A says that a standard error is 12. So a standard deviation will be 12 times the square root of 36, which is equals to 6. 12 times 6 is 72. B, we have the standard error of 3. So the standard deviation will be 3 times 6, which is 18. And C, we have the standard error equals 2. So we know the standard deviation will be 2 times 6, which is 12. And I believe that's all for this practice question.